Every time you turn the key and hear that familiar roar, you're engaging with one of the most fascinating and essential components of your vehicle, the engine. Today, we're diving into the heart of automotive power, exploring the intricate world of car engines. Car engines are marvels of engineering, transforming fuel into the kinetic energy that propels us forward. They come in various shapes, sizes, and configurations, but they all share a common purpose: to deliver reliable and efficient performance. To understand the inner workings, let's break it down into three major components that play pivotal roles in the engine's operation: the cylinder head, the cylinder block, and the timing system. Cylinder head, the crowning glory of the engine. It houses the combustion chambers, valves, and spark plugs. Think of it as the command center, orchestrating the controlled explosions that generate power. Cylinder block, the engine's sturdy foundation. This robust component contains the cylinders, where the magic of combustion happens. It also houses the pistons, connecting rods, and the crankshaft, transforming linear motion into the rotational power that drives your wheels. Lastly, we'll explore the timing system, the maestro behind the synchronized dance of engine components. Timing belts or chains ensure that valves open and close precisely, coordinating with the piston's movements to maintain optimal performance. As we journey through the intricacies of these components, you'll gain a deeper appreciation for the symphony of engineering that powers your vehicle. The cylinder head is a critical component of the engine, housing several key parts that contribute to the combustion process. Let's break it down. Cylinder head casting. Cylinder heads are commonly made from cast iron or aluminum. Aluminum is preferred in modern engines for its lightweight properties, aiding fuel efficiency. Cylinder head cover. The cylinder head cover acts as a protective shield, enclosing the cylinder head and its intricate components. It safeguards against debris and contaminants, maintaining a clean and efficient engine environment. Engine oil cap. The engine oil cap is like the gateway to the engine's lifeblood. It covers the oil inlet, ensuring that the engine stays lubricated for smooth operation and reduced friction between moving parts. Cylinder head gasket. The cylinder head gasket forms a seal between the cylinder head and the engine block. This ensures that the combustion chamber remains sealed, preventing leaks and maintaining optimal pressure. Valves. Valves are typically made of heat-resistant alloys such as stainless steel or titanium to withstand high temperatures. Valves act as gatekeepers, controlling the flow of air and exhaust gases in and out of the combustion chamber. Their precise movement is essential for optimal combustion and overall engine performance. Intake valves allow the air-fuel mixture into the cylinder, while exhaust valves let out combustion gases. Valve springs. Valve springs ensure that valves close promptly after opening, preventing any unwanted backflow of gases. These springs are usually made of alloy steel and are designed to withstand repetitive stress. Valve tappets, or lifters, transmit the motion from the camshaft to the valves. They ensure that the valves open and close at the right time, maintaining the engine's balance and performance. Rocker arms and pushrods. In pushrod engines, rocker arms transfer motion from the camshaft to the valves via pushrods. Rocker arms are typically made of steel or aluminum, and pushrods are often of steel. Camshafts. Camshafts control the opening and closing of valves by converting rotary motion into linear motion. Overhead cam (OHC) systems have the camshaft located above the cylinder head. Camshaft cap. The camshaft cap secures and protects the camshaft, a key player in controlling valve movements. It ensures that the camshaft operates smoothly and precisely, synchronizing with the engine's rhythm. Camshaft bearings. Bearings are commonly made of materials like bronze or steel to reduce friction and support smooth camshaft rotation. Spark plugs. The spark plug, a tiny but mighty component, serves as the ignition source for the fuel in the combustion chamber. During a compression stroke, once the piston going to reach TDC, an electrical spark generated using a spark plug is used to ignite the compressed air-fuel mixture to produce energy. Coolant passages. Channels within the cylinder head allow coolant circulation to regulate temperature. These passages connect to the engine's cooling system, ensuring efficient heat dissipation. Intake and exhaust ports. The design of intake and exhaust ports is a critical aspect influencing the efficiency of airflow in the engine. Factors such as port shape, size, and contour play a key role in achieving the desired turbulence and flow dynamics, ensuring the engine operates at its peak efficiency. Each of these components plays a unique role in the combustion process, ensuring your engine runs smoothly. The spark plug ignites the fuel, while the valves control the flow of air and exhaust. Now, let's move on to the second part, the cylinder block. The cylinder block serves as the foundation of the engine, housing crucial components that play a vital role in power generation. Let's explore these components. Piston. The piston, the engine's workhorse, moves up and down within the cylinder. It transforms combustion energy into mechanical motion, driving the crankshaft and propelling the vehicle forward. The highest position of the piston reaches in the cylinder is called the top dead center, and the lowest position is called the bottom dead center. During a compression stroke, the piston moves from the bottom dead center to the top dead center. This increases the pressure and temperature of the air-fuel mixture. Once the piston reaches the TDC, the spark plug ignites the mixture and produces energy. The thrust created due to the combustion of fuel pushes the piston to BDC. Connecting rod. The connecting rod links the piston to the crankshaft, converting linear piston motion into rotational motion. This integral component is essential for transferring power within the engine. Cylinder block. The cylinder block, the engine's foundation, houses the cylinders and provides support for key components. It's the structural backbone that endures the stresses of combustion and supports the entire engine assembly. Crankshaft. The crankshaft, the backbone of the engine, converts the reciprocating motion of the pistons into rotational motion. It transfers power to the transmission and eventually to the wheels, propelling the vehicle forward. Flywheel. The speed and torque from a car engine are not uniform. Because of this, the vehicle does not travel at a uniform speed. Therefore, the fluctuation affects the life of other parts. To avoid this, a flywheel is used. The flywheel is mounted on the crankshaft to balance the vehicle speed. The flywheel has two main functions. First, to store the energy generated in the power stroke and use it in the preparation stroke, and second, to ensure the uniform rotation of the crankshaft. Oil pan. The oil pan, or sump, positioned at the bottom of the engine, is the reservoir for engine oil. It collects and stores oil, ensuring a constant supply for lubrication. Coolant jackets. Coolant jackets are channels or passages in the engine block that allow coolant to circulate, helping regulate the engine's temperature. These components work together harmoniously. The piston moves up and down, converting fuel into mechanical energy. The crankshaft then translates this linear motion into rotational motion. Now, let's move to the final part, the timing and drive belt systems. The timing and drive belt systems are the precision choreographers of your engine's performance, ensuring every movement happens with perfect timing. Let's dive into the synchronized dance of these crucial components. Timing chain, belt. The timing chain or belt is the backbone of the engine's timing system, linking the crankshaft to the camshaft. It ensures precise synchronization between these two critical components, dictating the timing of valve and piston movements. While both timing chains and timing belts serve a similar purpose in an internal combustion engine, they differ in their construction and materials. Timing chain is made of metal, typically steel, while timing belt is made of reinforced rubber with toothed grooves. The choice between a timing chain and timing belt is often influenced by factors such as cost, engine design, and manufacturer preferences. Some engines use timing chains for their durability, while others opt for timing belts for their quieter operation and lower manufacturing costs. Camshaft sprockets, intake and exhaust. Think of the camshaft sprockets as the gear maestros. They connect to the timing chain, regulating the opening and closing of intake and exhaust valves, influencing the engine's overall performance. Crankshaft sprocket. The crankshaft sprocket connects to the timing chain and is responsible for synchronizing the rotation of the crankshaft with the camshaft. This coordination is vital for maintaining precise valve and piston timing. Timing chain cover. The timing chain cover protects the timing chain and associated components. It also houses the timing marks, facilitating proper alignment during maintenance and ensuring precise coordination within the engine. Now, Let's switch our focus to the drive belt system, also known as the serpentine belt. This belt is a multitasker, driving various engine components such as the air conditioning compressor, water pump and alternator. It ensures that these components work in sync to support your vehicle's electrical and cooling systems. Water pump. Tucked away near the heart of the engine, the water pump is an unassuming yet crucial component that plays a vital role in maintaining the optimal temperature for your engine's performance. Its primary task is to circulate coolant, ensuring that your engine stays cool under the hood, even when things heat up. Tensioner and idler pulley. The tensioner pulley in the drive belt system maintains proper tension, ensuring the serpentine belt stays snug and efficient in driving the various engine accessories. The idler pulley in the drive belt system helps maintain tension and alignment, ensuring smooth operation of the serpentine belt. These components, whether in the timing or drive belt system, work together in precise coordination, regulating the opening and closing of valves, driving engine accessories, and optimizing overall engine performance. This synchronization ensures your engine operates with efficiency and reliability. As we conclude our exploration of the internal combustion engine, we've unveiled the intricate world beneath the hood by dissecting three crucial components: the cylinder head, cylinder block, and timing system. In the first part, we delved into the cylinder head, where combustion takes center stage. From the casting that forms its structure to the valves and spark plugs orchestrating the combustion dance, every element plays a vital role in propelling your vehicle forward. Moving to the heart of the engine, the cylinder block, we discovered the foundation that houses the pistons, connecting rods, and crankshaft. These components work in harmony to transform combustion energy into mechanical motion, creating the power that drives your vehicle. Finally, we explored the timing system, the conductor of the engine orchestra. The timing chain, camshaft sprockets, and various tensioners ensure precise coordination, regulating the opening and closing of valves and the movement of pistons. This synchronization optimizes engine performance. Together, these three components form a symphony of mechanical precision, turning fuel into motion and powering your journey. We hope you enjoyed this educational journey into the heart of your vehicle's engine. Remember, each component plays a crucial role, harmonizing to make your drive a smooth and powerful experience.